Listen, guys, I have quite a busy day, guys, because my plastic shredder is broken. So, and I'm doing my first ever scientific run of the machine, okay? We're doing one type of plastic. It's gonna be weighed. It's gonna go in the machine, and then we're gonna get the oil analyzed. And so because of that, we have to limit variables as much as possible. So this is all I'm putting in here is HDPE, but the catch is I have to shred it by hand since my shredder's not working. And now, of course, I cannot shred this like a machine, but I can cut it into, you know, some decent sized bits the best I can. But I have quite a bit of pieces to do here today, so it's gonna be quite a busy day. Just up in here chopping plastic. So that way we can get this good run going, you know, where we can start to get more scientific with it. Definitely was unfortunate timing on my shredder malfunctioning. But it is what it is. But how's everybody doing today, though? What is it? Is it Monday? I lose track of time, guys, because, like, I don't, like, on weekends, I work as if it's the regular day. So I don't even know what day of the week is. I think it's Monday. How's everybody doing this Monday? I guess I'm a little bit early for anybody that's in the States. You probably are at work. I guess I'm at work too, right? We're all at work right now. I guess anybody in Asia or Eurasia, it might be nighttime for you guys. But wherever you are, I appreciate you guys being here. But it's gonna be a good run today. And I just want to let you guys know, like, okay, so I've been like chopping plastic for the past 40 minutes, and this bag is almost full. But I promise you guys, like, this was probably about like 15 jugs, like sweet tea jugs, and like these but bigger, the gallon ones, probably like 15 of them. And guys, I promise you, this thing probably isn't even like, probably just 2 pounds. Like, it takes so much plastic to get such a little weight. You know, the good thing about the machine is you can put big loads in that machine's mouth, you know. And so we can put a lot of plastic in that machine at one time, but only if it's chopped or shredded. You know, that's the catch. It has to be chopped or shredded to have the most amount of plastic in there. And then on top of that, the more plastic you put in at once, the more efficient the machine works. So it's better in every way to just load it up as much as possible. And that's why it's so important to have a shredder when it comes to process efficiency, man hours, all that type of stuff. You know, my shredder was never that good to begin with. I'm looking to get a new one, or either have one. I'm either gonna buy a new one or have one built. You know, I'm a welder, so I can weld all the stuff together. I just don't have a CNC table to cut the gears and stuff out. But I'm talking to a guy that might be able to do that for me. That might be the best way, right? We don't have to worry about shipping, crazy shipping prices. But yeah, I mean, it's a long time coming. And you know, here's the thing, guys. We're trying to get the variables as little as possible. And I do really wonder, because I'm doing a lot of sweet tea and like lemonade jugs here. I don't think that they would really affect it that much. I know that, you know, there's some residual sugar. The water, of course, will come over, but that easily separates from the oil. But, you know, the sugar is such a light chemical chain compared to carbon that I think the sugar will literally just turn into the natural gas, right? Just turn into like, just break down into literally carbon monoxide, or like the literal bonds of it, you know, literally just the carbon and hydrogen that make up the carbohydrate, you know, because it is a carbohydrate, or it might literally just turn to carbon for that matter, right? Because sugar, it's such a light hydrocarbon. It's not even a hydrocarbon. Well, I guess technically everything is, but, you know, it's not a petroleum chemical. And obviously sugar has energy in it. You know, you can literally set sugar on fire, but the calorific value of sugar in comparison to something like plastic is minuscule. So I don't think that the sugar is going to affect this run that much, because I think it's just going to be completely cracked to a degree where, you know, it won't be noticeable. But we're going to see, because we're getting the oil from this run analyzed under mass spectrometry. So we're going to see, guys, if indeed there's any sugar that comes over. There won't be, but like maybe some traces of something else, like that resemble decomposed sugar on a chemical level, right? I mean, this reactor breaks everything down into its basic chemical bonds, the carbon and hydrogen bonds that make up everything. So that's why you can put anything in this reactor that's organic, anything. It's just a matter of plastic is such an amazing thing to put in there because plastic has such a high calorific value. I mean, we all know that. Look, set a piece of plastic on fire. See how long it burns? It burns as long as diesel fuel, right? If not longer. So if I go and I put a bunch of grass in my machine, it's not gonna give us that much energy per watts of energy that goes in. But plastic will give you probably almost more than anything else on Earth. The only other thing that probably will give you as much is motor oil itself being put in the machine, or crude oil itself, right? Because plastic is some dense stuff. That's why I say plastic is like the solid form of crude oil. It essentially is, because your solid is the most compact form of a molecule, right? And it came from a liquid, right? It came from a liquid, and liquids are already more compact. And crude oil was already a very energy-dense liquid, so you make that thing a solid, and it's super energy-dense. So that's why I use plastic. I mean, and also, I most importantly use plastic because this is a solution to dealing with plastic waste, to truly destroy it and get rid of it, not just turning it into another water bottle, right? That's the idea. I always tell people this isn't a power plant. We're not up in here trying to produce energy. We're not trying to generate electricity. All we're trying to do is get rid of plastic, and we just happen to make fuels as byproducts of the process that we have to do something with, right? Because otherwise you just have a whole bunch of waste that's energy, so that'd just be stupid. Might as well do something with it, whether it's selling it or whether it's somehow incorporating it back into the machine to where the machine has no energy cost to run. Whatever we do with the energy, that's not the point of the machine. Just like a recycling plant. See, like a regular recycling plant that takes one water bottle and turns it to another water bottle. Nobody's up in here asking what their energy consumption is, because they consume a lot of energy. They consume a lot of clean water, and pollute it with microplastics for that matter. But nobody's asking that because they're not saying that they're making electricity. And I'm not saying I do. I'm just saying I'm making fuel. I'm not saying I'm making a profit of fuel, but I am saying that I am processing plastic in a way which chemically destroys it where it's no longer plastic, and that is absolutely the case. Absolutely the case. Because for the fuels to even exist, from the natural gas to the any liquid product to even exist, and even the carbon, for it to exist, the plastic has to undergo a permanent chemical change where it is no longer plastic. It's like if you take a piece of wood, a piece of firewood, right, and you set it on fire, and then the ashes left over, right? Those ashes are not wood anymore. The smoke is not wood. It's a different product. It's undergone a chemical reaction, and the chemical reaction we're doing here is thermolysis, or basically just using heat to break apart chemical chains, right? When you have something set on fire, it's actually an oxidation reaction because the fire is burning, right? It's hot, of course, so the heat is breaking things apart. However, oxygen needs to exist for a fire to burn, and that oxygen, with that heat of the fire, is going to react with all of the chemical bonds that are breaking apart, which releases dioxins, right? Not all dioxins are bad. Carbon dioxide is a dioxin, for example, right? And obviously that feeds trees. But some dioxins are straight up like super toxic and cancerous and lethal, right? At the same time. And so that's the difference. I mean, and burning something is very uncontrolled because you have this emission, the smoke that comes out, and it has to go somewhere, right? And you have to clean it up. Versus with pyrolysis or any of these types of processes where it's a reactor, by nature of it being a reactor, everything is kind of, kept in cycle and in situ is closed. It's not just being emitted out. So, guys, look. We still got a long way to go. I still got a lot more plastic. I want to fill up this whole bag, at least one bag full of HDPE. I've already been here for an hour, okay, before I even went live. These are just like oatmeal containers, right? So, I mean, once again, there's probably some residual little freaking scraps of oatmeal. Oatmeal, just like sugar, is a carbohydrate, and carbohydrates, I mean, our body can digest them, so they're very, very short chains, very, very short chemical chains. I'm sure the reactor will destroy them to such a degree where they're not even like, you can't even pick it up on the mass spectrometer. It literally would just be the atoms of the hydrogen and carbon that made up the carbohydrates, right? That's what everything is, guys. You know, the only difference between the food we eat and the food that engines eat is the calorie. You know, when you break it down to the chemical level, the density of those hydrocarbon chains, right? Because when it gets to a certain degree, when the hydrocarbon chains become so long, natural things such as bacteria, fungi, animals, blah, 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 cannot break down these things. That's why plastic is not biodegradable. The hydrocarbon chains within the plastic that make it waterproof, that make it, you know, last so long, all the properties we love about it, they actually make it indigestible by every type of bacteria and fungi on Earth. And I know people are like, oh, there's some fungi that can eat plastic. Look, guys, they're not telling you everything. They're telling you, it's just like when they did the recycling stuff, okay? They said, we're going to start recycling, but they only recycle PETE and like HDPE, which are like 2 out of like the 10 types of plastic. Yes, there's fungi that can eat some plastic, but the only plastic it can eat is like styrofoam, you know, or something like that. It's like one type of plastic. We're not going to solve the plastic crisis by a fungi that eats only one type of plastic. We need a device that can process every type of plastic. That's why we're in this debacle to begin with, because they lied to the public and said, we're recycling everything. Okay, we're recycling everything, when actually they're only recycling 2 types of plastic, right? And that's only if they actually recycle it and don't just send it overseas. And then obviously there's millions of types of plastic where they put that little symbol on the back, little triangle to make you think that it's recyclable. They're lying to you. If you look it up, actually half of those symbols with those numbers can't even be recycled. Like number 7s can't be recycled. PVC really isn't recycled. You know, so look, I've been to some places where they're like the plastic bags can't be recycled. I'm like, what? Isn't that like the simplest thing? Well, whatever. It's all about contamination. Look at this thing. This has mold on the back of it. You think the machine gives a damn about some mold? No, but if you're turning this into a new fresh bottle to be sold at a virgin market, you can't. That's unacceptable, right? That's a sanitation issue. That's not going to work. But this machine is working at temperatures so high that there's nothing living that can survive. I mean, look at that. Literally mold inside of this thing. It doesn't matter with the machine. That's the point. That's the point of this machine, guys. It's the advantage of the overall like consumption of a fire, because you know fires are like all consuming. They don't care a fire does not care what you put in it. It's going to destroy it. So we have the advantage of just like that indiscriminate destruction of a fire with the control of science, with it being a reactor, right? So we're not just releasing stuff in the air indiscriminately, but we're destroying everything indiscriminately. So, you know, the only reason I'm even doing all of this, and, you know, taking one type of plastic, trying to make sure it's as clean as possible, shredding it up, is for the sake of science. But if we were just like, let's say it was the end of the world, we needed to make fuel, we had this thing running off of solar panels, we needed fuel for our farm truck, put whatever the hell you want in there. Put any type of plastic, mix it with any type, put roadkill in there, put your enemies in there. It doesn't matter, you know. Put everything in the machine. You could put what do you call that? You could put literal pesticides in there. You could put Roundup in the machine. It's gonna break it down. Like it doesn't care what you put in there. Put in motor oil, put in vegetable oil, put in bacon, put in food, put everything. Dirty diapers. It doesn't matter because the machine breaks. It just works on the basic principle of organic matter being broken apart by heat, and that does not matter what it is, no matter how dirty it is, no matter how clean it is. You could put Diddy's freaky ass in here. The machine will not, it won't even stutter, you know? Even with all his baby oil all over him, it won't matter. It will not make a difference, I'm telling you now. So that's the advantage of this process, and that's why I use this process. Because, you know, you look at ocean plastic, it's full of seaweed, it's full of salt, it's full of, you know, I'm sure there's fish in there, all types of stuff. There's no way we're gonna take ocean plastic. I know they're like, oh, we make them sunglasses out of the ocean plastic. Yeah, you make the sunglasses out of like 1% of the ocean plastic, the rest goes to the landfill, all right? Just simple logic. There's no way that you can take this plastic that literally is crumbling apart from the salt and the sun of the sea and make anything with it. It's literally like crumbling. No, other than it just becoming microplastics and becoming smaller and smaller when you put it in the landfill, and then the leachate water from the landfill ends up in the water supply because we know that those things leak. Well, the best thing you can do other than that, because you can't recycle that, is burn it, right? Or put it in a reactor, which burns it without the fire. You see what I'm saying? Thank you for the $2, Willis, on the Cash App. Much love to you, Willis. I appreciate you guys for your love and support of this project. And this project's 100% crowdfunded. So, you know, your donations go so far, guys. And look, every donation, you guys are contributing to the project into history. Because like I said, we're 100% crowdfunded. I don't have investors. You know, this is us. We're doing this. Well, I appreciate you guys so much. But yeah, I'm just spinning the game here, guys. I'm spinning the game as to why I even am embarking on this journey. Why am I even risking my life on this journey? Because, listen, and I know pyrolysis has been done before. I know it's been done before. But I'm doing it a different way. I'm doing it a different way because, for one, the first way that I'm doing it so differently is by sharing it to the public. Okay? Because let's all be honest. No matter who you are and what you say, most people don't know what pyrolysis is. Most of these companies want to keep it so secret until they do it. But guess what? They never do it because you don't have the public support. You don't have the public backing. You can build the perfect machine, but if once you go to make it and you don't have the regulatory bodies because you don't have the political side right, you're not going to get anywhere. But if you can educate people and share the mission with everybody and get everybody excited, just as excited about it as you are, then it's a lot easier to get these things implemented, okay? It's sad that we live in a world like that, but, you know, look, that's why nuclear energy isn't a thing, because of politics. It's not even because it's not good energy, right? It's the best energy, and it actually has the least amount of casualties. But, you know, it's the same thing here with this stuff here, because you know what? They don't even classify this plastic oil, which does burn in an engine. They don't classify it as a synthetic fuel nor a natural fuel, because it's kind of in between, right? Because plastic this is technically a natural product, because crude oil is natural. This is made of crude oil, but it's been synthesized, so it's technically a natural product if you really think about it. But then it's a synthetic product because it's like crude oil that's been processed, kind of like a Cheeto is natural because it's made of corn, but you know, it's been so processed you would never find a Cheeto in nature. But then the question becomes, okay, if we take this product, which is a synthetic product, but then we break it back down to its natural components, which is where it came from, a natural product, then what the hell is it? It's kind of a hybrid, right? So they don't, you know, there's not a classification for the fuels, and that's kind of an issue, because without the classification, it's hard to get, you know, the EPA to certify. You know, there has to be a whole new certification for this fuel. Kind of like ethanol gasoline is not the same. It's a completely different label than gasoline without ethanol, right? We gotta have things in place where this is just a separate product that could be, you know, the best thing you can do with this is blend it with real gasoline, real diesel. If you do that, you won't even tell a difference in your vehicle. That's the best thing you could do. Of course, it can replace it. We've seen that. I've ran every type of engine on it except for jet engines. And come on, let's all be real. We know a jet engine will drink this up, no problem, right? But you know, I think blending it is the best way, because then you're gonna reduce the amounts of needed actual drilling gasoline. But then at the same time, you can supplement that with something that's getting rid of waste at the same time, right? I think that's the best thing that we could do. I'm actually starting to run out of plastic here, believe it or not. Don't have that much left, and it doesn't really matter. Here's the thing, the machine really doesn't have a minimum amount of plastic, but like I said, it becomes more efficient the more plastic you put in. So there's huge advantages to putting in tons of plastic if you want you know, efficient numbers. But this is a scientific run. This is for analysis. This is not for efficiency. So I'm not really concerned with that. But I do want to put in as much as possible, right? Because the more you put in, the more oil you'll get out. Just all that type of stuff. It just makes everything better, the more plastic you put in. So we're going to put in as much as possible. But without being able to shred it finely, you do limit yourself quite a bit. So yeah, like, look, we're coming together, but I assure you this bag is no more than 3 pounds at most. You know, I love to put 30 pounds in there. I don't even have 30 pounds of plastic. This was a whole 55-gallon drum full of HDPE. You cut it up and it reduces to a single bag. And then this single bag doesn't even weigh 10 pounds, guys. The amount of weight of plastic is nothing, I'm telling you guys now. It takes so much plastic to weigh such a little amount, which is actually kind of a good thing when it comes to logistics, you know, transporting it. But it takes up so much volume. It takes up so much space, especially before it's shredded. You know, that's an issue. Because it doesn't matter if it doesn't weigh anything, if you can't fit 1,000 tons of plastic on a truck because it just takes up too much space, and there's really no logistical advantage, right, at that point. Even though it weighs nothing, because you got to do the equivalent amount of truck drives back and forth as if it were very heavy, right? No, guys, before I had my shredder, I used to do this. This stuff blisters your hands pretty bad. I used to do this all the time before my shredder back in the day, guys. So this is really a throwback for me. You know, I've been doing this for 4 years. My first year of doing this I have the videos, but I never published the videos online. And these are the types of things I would do. I guess that's dedication, right? But I'll tell you now that I will not be stopped. And any circumstance of life, such as a shredder breaking, or an accident, you know, an accident I get myself into, or an accident I get my computer into with the rain, nothing's gonna stop me. You know, nothing has, nothing will. I've been doing this too long to let any circumstance stop me, right? Because the circumstances may or may not be in my control, but my reaction to them certainly is in my control. And I just refuse to give up. I mean, at this point, I've been doing this so passionately so long. If I gave up, I'd be losing more than if I kept going, right? Period. That's just how it is. I mean, what the heck? Look, what am I going to do with all this stuff if I give up? What am I going to do with this whole reactor? In fact, this is my 5th reactor. What am I going to do with all 5 of my reactors if I give up? I'm just going to donate them to auction, just throw them in the scrapyard? No. You know, at this point, guys, the reactors got to go in museums. And the only way they're going to go in museums is if there's a legacy built with them. And the only way a legacy is built with them is if I continue to work hard to get this where I want it to be. Where we can deal with every type of plastic. We can have machines on ships. We can have machines in landfills. We can have machines in every single city on the world dealing with plastic waste at the source. And plastic is no longer a problem because it's not even getting to the ocean, because it's being dealt with right then and there because we're making value out of it, right? That's what the goal is. That's what the mission is. And at this point, until we get there, there's no stopping. But guys, it's about to happen really quick. Look, I'm telling you guys now, 2025 is going to be a humongous year for this project. Because look, we're starting to get more scientific with it. Look, we're doing this because look, we do these type of analysis. I get a research paper out. I can get big federal grants. We get government contracts, city, country contracts, get this machine set up in many places, get this machine running off of solar. 2025 is going to be a humongous year. In fact, I already can tell, and I'll tell you guys now, 2025 is going to be the last year of me doing this like this, in a non-professional way. Now, at what point in 2025, I don't know, but it will be the last year. Mark V will be built in 2025. Oh, what a oh, look, I didn't even think about that. Mark V in 2025. That's cool. Mark V in 2025, we're doing it, all right? Because look, guys, all I got to do is make Mark 4.5 continuous and do a little bit more engineering on our condenser system, and then the machine's done. The design is out there, it's done, and there's nothing stopping me back from just going ahead and making Mark V other than money. That's it. Because the design is down. The process of how the machine runs is down. You know, obviously the team is down because I got you guys, and I know you guys are so skilled. You know, I know we got welders, we got process engineers, we got, you know, every type of person in the family. So all it takes is, you know, I know you, a lot of you guys have applied on the website too. So, you know, I'm confident we already got the team, guys. I know I may not have responded. In fact, I don't really respond to most of the applications that come through. I save them because, like, I know right now I'm not hiring anybody. I can't hire anybody right now. But I save them because when I do hire everybody, I'm looking right there at those applications first, right? I'm looking right at the applications first. And we got the team. You know, we got the team. And it's going to be a no-brainer. It's going to be such a quick transition from doing it like this to doing it professional. I promise, I assure you. 2025. 2025. That's why I named this machine Mark 4.5, because I told everybody Mark 5 is going to be the first professional industrial machine. And so this was the last transitionary machine between going completely professional, but still collecting tons of data, and of course learning a lot. Every machine I learned so much, but this machine has been so good to me because I've built it so good. You can go and look at the videos. Every single weld I did, everything. It's been built so well, and like it's vacuum tight. I can pull a really good vacuum on it. I've never actually seen how deep of a vacuum I could pull. The furthest I went was over half an atmosphere. Right? But I never actually looked into how deep I could go. Because I really don't like just sitting there for 20 hours waiting for the vacuum to be pulled. Because I know that once the machine is actually, under production, the vacuum kind of dies pretty quickly. It goes from like half an atmosphere to a quarter of an atmosphere because the vapors from the plastic that form, they fight the vacuum a lot. So there's not really much of an advantage to getting it to a super deep vacuum because it won't stay there anyway. But what time is it, man? 10 o'clock? Oh my goodness. Yeah, I gotta get this run started. It's 10 o'clock. The average run takes about 3 hours. And I want to do some distillation today too. Guys, I'm setting up a vacuum distiller. And I know last time I set up my vacuum distiller, I didn't turn my vacuum pump on. And that's what got me blown up. I have a pressure relief valve. I'm going to have pressure gauges on it. I'm going to have several different valves to where if I don't turn the vacuum pump on, I can turn on a different valve to just make it an atmospheric distiller. But guys, the reason why I'm trying to make this distiller a vacuum distiller, and why my machine runs under vacuum too, is actually because when something is under vacuum, it actually takes less energy to break it down than if it were running under atmosphere. And then there's some other advantages to the machine running under vacuum. It actually makes the machine safer because the machine is way less likely to explode. I've actually never had a true explosion of the machine. I've had some depressurizations. The only thing that ever exploded was my distiller, and that didn't even really explode because there was no shrapnel, right? So technically, that was just a depressurization too, a very intense depressurization at that, but it was still a depressurization. So I'm glad. If that thing, shot shrapnel, that would have been bad because there was some borosilicate glass on that distiller. So yeah, I probably would not be here right now if that thing actually exploded. But I'm sure most people would classify that as an explosion if you're in a ball of fire running for your life, like Harriet Tubman, right? All right, so we're almost done here. Actually, I'm quite surprised that all of this plastic ended up just taking up this bag. But what we're gonna do, I'm about to end the live stream on Instagram. I'll move over to TikTok, but I'll be live again when we're actually running this thing on Instagram, guys. You guys on YouTube, I'll keep the live stream up on YouTube until I'm done chopping all this plastic. But I'll go live on TikTok right now. So yeah, guys, on Instagram, I'll see you guys in probably an hour or two when I actually start to run the machine. But we got this scientific run going, though. So I'll see you guys in a second. Oh yeah, sorry guys, I haven't been reading comments. Obviously, I've been occupied. But when I do the live stream of us running this, I'll be engaged in the chat and all that type of stuff. I'll be engaged. It's just that right now, can't really be looking up at the screen. So what we have is, we almost have a full bag. This is crazy how long this is taking. In fact, I wonder how much this weighs. Let me get my scale, because I actually am interested. It might annoy me if it's not a lot. All right, we're gonna see how much this weighs. I called it. It's 5 pounds of plastic. All of this work, no, it's not even 5, it's 4.5. All of this work, hours of cutting, for not even 10 pounds of plastic. Hey, it's a hard knock life. It's a hard knock life out here. We're at 4.5. I have a little bit more plastic to cut up, but not that much. So, let me tell you guys on TikTok what we're doing. So guys on TikTok, guys, I am right now preparing for my first ever very scientific run of my plastic to fuel reactor over here. Oh, I can't turn this damn camera. God. All right, the plastic to fuel reactor. I'm preparing my very first super scientific run where we're gonna put in one specific type of plastic, a measured and weighed amount, and then I'm going to take the oils that come from this and send them to a lab to be analyzed. So what we're doing is we're taking HDPE, high density polyethylene. This is most commonly found in milk cartons, you know, the gallon jugs, these oatmeal containers. And I'm just cutting this up because my shredder is broken, guys. My shredder is not working properly. It's not like broken, like it doesn't like turn on, but the blades on it are just acting so stupid. And the blades are, I just sharpened them too. I sharpened every single blade. I repositioned them, and it just isn't like shredding properly. I don't know how to describe the nonsense that thing is doing, but you know, it's not gonna stop me. Too ambitious. If I have to sit here and cut plastic until the end of time in the world, I will. To destroy this. I am the Thanos for plastic waste. Okay? I am the Thanos to plastic waste. So anyways, I've been cutting for, what is it, almost 2 hours now total? And I'm continuing to cut. And of course, we're going to live stream when I actually am running this in the machine. But right now, as of right now, just cutting this stuff up. And it's taken years to do. And I do want to appreciate all you guys that donate, because this project is 100% crowdfunded. It's been 100% crowdfunded. You know, there's no investors in this. This is us. This is the world coming together to deal with this plastic waste. So any donations help so much. I appreciate you guys. But yeah, we're at 4.5 pounds. I want to get to 5 pounds, guys. You think it's possible? Because look, I know I just started the TikTok live stream, but you guys on YouTube have been in here and you've seen how much I've been cutting the plastic and how little, you know, the weight goes up. How little the weight goes up. You know, you guys have seen it. Some Myers soap bottles. This is HDPE too. I'm taking the wrapper off because the wrapper is going to be some other type of plastic. You see, this is why it's so hard for traditional recycling to even work, because there's too many damn different types of plastic in one given thing, right? Like, you know, and you know, can you really blame the manufacturers? It's really because they do this for us. Like, nobody would buy this as much as they do if there was no wrapper on it, right? You know, it's like an appealing thing to human psychology. So you can't really blame the manufacturer for putting all these different wrappers and all these different types of plastic together and these dyes on it. But, you know, what should have been the case is the regulatory bodies shouldn't have allowed this much different variety and things to come out until we had proper solutions to deal with all these different types of plastics, which we don't. In fact, I might not even be able to use this because this is like really sticking on here, and I'm not trying to mess up the variables of everything I've done for one damn bottle, one damn soap bottle, because that's what's going to happen. If I don't get every single piece of this sticky label off, then it's not 100% HDPE. It's HDPE with this little amount of soap. So screw that thing. Wasting my time. We're actually almost out. See, I gotta be careful. This wrapper is too like embedded on here. I can't get that off properly. Shoot, we're running out of plastic, guys. I don't know if we're gonna be able to get to 5 pounds. Keep it real with you. I don't know, because we're running out. I don't have much that is not gonna be not gonna affect the variables too much right now. I don't have much plastic left that isn't full of labels and stickers and crap. And guys, look, the only reason I'm not putting every type of thing in here is for science. That's the only reason. This machine will gobble it all up, okay? Like Lizzo and some biscuits. This machine will gobble it all up without problem. But for the sake of science, if I go ahead and I put too many things in here with all these different labels, then our analysis will not be conducive to a singular type of plastic, you feel me? It will not be conducive to a singular type of plastic. It will be conducive to a broad mix. Thank you for the $10 super chat on YouTube, Facing Reality. Will a wood chipper work for cutting the plastic? I've actually tried that before. The wood chipper cuts it to the same degree I'm cutting it now by hand. Really big, flaky chunks. And on top of that, wood is much harder than most of these plastics. So, like, plastic bags just end up getting stuck in there. I'm going to get a new shredder, guys, but unfortunately right now, I'm not in the position to get a new shredder, so I'm just doing the grind, guys. I'm doing the grind. Look, we're all doing the grind. It's Monday. All right, guys. Oh, we got some. These bottles might work. This is HDPE too. I don't know about this lid though. See, that's the thing. If I'm not 100% sure what type of plastic it is, it's not worth messing up my variables. Let's see if I can cut this and maybe separate it from the lid and this wrapper. If not, I think we maxed out how much plastic we're gonna get in there. Now we have more than enough plastic to run the machine, without a doubt. But I just want to fit in as much as possible. I was explaining this earlier, but the more plastic that goes in the machine, the more efficient the machine operates. The more efficient the machine operates, the better everything is. Now, this is a scientific run for analysis, not for energy measurements. See, the reason why I haven't done my big energy measurement run yet that I want to do is because I need to, for one, have as much plastic in there as possible. I've never maxed out the capacity of this machine. All right, I put in 10 pounds at one time. That was my biggest run. This machine can take in at least 30 pounds. And if I've shown you guys anything, 30 pounds of plastic is a lot because this is not even 5 pounds. This is not even 5 pounds. So 30 pounds, do the math, that's 6 bags full of shredded plastic. That's a lot of plastic, right? If anything you guys are learning right today, it's that. So imagine 30 pounds going in that machine at once. I want to do that. We gotta put 30 pounds in that machine's mouth. All Diddy on that. It's Mando. But guys, when I come back with the live streams, we're gonna see the plastic turns to oil. Okay, it's gonna be a really fun live stream to watch. But I gotta be recording so much data and recording so much footage for the sake of science while I do this. That's the thing. Science is annoying. It's necessary, but let's be real. It is annoying because you have to record so much. Yeah, that's it. That's pretty much all these other things have too many wrappers on them. All right, guys, let's see how many pounds we got. Look, there's still some plastic in here, but all this plastic is too many variables. It's gonna mess me up. It's gonna make all this hard work I've done for nothing. How many pounds of plastic? All right. We are at 4.8 pounds or 2.2 kg. Not much at all. But I've been cutting as if it's a lot. Because it's taken 2 hours to get these super, super rough cuts. They're gonna fit in the machine. I have to load them in the machine to the front. But so you guys seen the hard work here. So anyways, I got a lot of stuff to do for this video. A lot of unseen stuff to set up to get all this data collected. But I'll be live again, guys. Thank you for stopping by. Thank you for donations. Thank you for your support. Like I said, I'll be live again in probably 2 hours. So I'll see you guys then. And thank you for stopping by.